This is similar to the last problem in the last video, so I'd like you to hit pause and give this one a try. Let's see how you did. First we need to isolate the square root, so I'll add 25 to both sides. 3 times the square root of 6b plus 3 equals 75. My personal preference is to divide both sides by 3 in this case, giving me the square root of 6b plus 3 equals 25. 25. Now I'm going to square both sides to get rid of the square root. Squaring a square root just gives you the radicand, so 6b plus 3. 25 squared. This one comes up a lot. You really should have it memorized. It's 625. The other thing that's related to this is 5 to the 4th. That is also 625. It comes up a decent amount of times where it's just worth knowing that as a fact. To solve this, we'll need to subtract 3 from both sides, so 6b equals 622. And then divide both sides by 6. This is going to be weird, but b should equal, doesn't go in there evenly, so 311 over 3. That is an ugly, ugly number. That's what we've got. So let's check it. Not fun, but we got to check it nonetheless. 3 times the square root of 6 times 311 over 3. What a gross number. Plus 3 minus 25 should equal 50. Okay. Well, 6 over 3 is 2, so this is 622 plus 3 minus 25 equals 50. 622 plus 3 is 625, and as we just talked about, 625 is 25 squared. So the square root of 625 is just 25. And 3 times 25 is 75, and 75 minus 25 is 50. So this checks out, and that odd number is our solution. Let's look at another one. Now this one's different because you happen to have square roots on both sides of the equation, and the radicands are different, which means our normal first step is impossible. So this says the square root of 4z minus 3 equals the square root of 3z plus 2. We really can't isolate the square root. So next best thing to get started, we can't isolate them, but we can just square both sides from the beginning. And the nice thing about that is squaring a square root gives you the radicand. So 4z minus 3 equals 3z plus 2. And if we solve this equation, we get z minus 3 equals 2. Add 3 to both sides, z should equal 5. We're not done. We still need to check it. So going back to the original problem, 4 times 5 minus 3 should equal the square root of 3 times 5 plus 2. Well, 4 times 5 is 20, and 20 minus 3 is 17. 3 times 5 is 15, and 15 plus 2 is 17. That's true. So we've confirmed that z equals 5 is our solution. So that one wasn't too bad. Just can't isolate them in this case, just need to start squaring things.